Thank you. All right, guys, are there any questions over any of the homework problems? Question over the homework from yesterday. We good with the homework assignment from yesterday? Hopefully y'all notice with yesterday's assignment with areas of both, it's really just formula based. Because Heron's formula, you find the value of S, which is all the sides added together divided by 2, and then plug that into the area formula, which area is equal to S times S minus A times S minus B times S minus C. Take square root of the whole thing, and that gives you the area. So just plug in the information in. Now, what we're looking at today is law of sines. Law of sines. And we're going to do this one here together. Now, tomorrow, again, we're going to be doing law of sines again, because there's two different sections that we'll be talking about with law of sines. Today, the ones we will be doing or dealing with is we're going to be given two angles and a side length. We're going to be given two angles and a side length. Tomorrow's law of sines is going to be given two side lengths and an angle. So today's two angles and a side. Tomorrow's two sides and an angle. Friday, we're going to start with law of cosines, which will give us two sides and an angle, or two angles and a side. We'll be dealing with law of cosines on Friday. Okay? Now, Thursday and Friday, I will be doing the lesson with y'all. I just won't physically be here. Because, again, Thursday and Friday is the start of regionals, and they need me to be running the clock. So, again, the video like we did yesterday, same exact thing. Now, again, part of the reason we're doing this, especially with the video, as you've seen already, is really revolving around these formulas and plugging the information in and solving for what we don't have. So with law of sines, there's two different formulas that we have, and y'all already have that written in. Now we have one where we have sine of A over A, sine of B over B, sine of C over C. This here. And this is used to solve for a missing angle. If we're solving for a missing angle, we're using one of these three here. If we're solving for a missing side, we're using the other one, A over sine of A. B over sine of B is equal to C over sine of C. Now we won't use all three, we'll only use two at a time. So we're using one of these two formulas here. And these here, the reason that they're helpful or the reason that they're useful is because we need them to solve for the missing sides or angles of a triangle where the triangle is not a right triangle. It'll still work for right triangles, but specifically we use this when the triangle is not a right triangle. And the reason for that is because our sine of an angle is equal to opposite over the hypotenuse, what we had from the last chapter, only works if the triangle is a right triangle. If the triangle is not a right triangle, we can't set this up. We can't use this here or any of the other ones that we have that cosine of an angle is equal to adjacent over hypotenuse. Those only work in right triangles. So this here is the first one we're going to look at. Now there's three pieces of information that are missing. We're missing the measure of angle A, side length A, and side length C. These are the three pieces of information we're missing. Angle A is going to be the easiest one to find, because this here is still a triangle. So we know that these three angles add up to what? So we can add 107 and 25 together, which gives us 2 carry the 1, 132. And we can subtract 132 from 180 because any three angles in a triangle still always add together to be 180. So the measure of angle A is 48 degrees. Any questions on this so far? Any questions over anything we've done so far? Now, our general formula for this here is our sine of A over A, or sine of B over B, sine of C over C, or the flip. Now here we're solving for what next? Angles or sides? Sides. So, get rid of that. Here, we're not going to use these here because we're solving for a side. So we're looking at this here as A over sine of A, B over sine of B, C over sine of C, where little a, little b, and little c are just side lengths. Capital A, B, and C are angles. So it's really side over the angle opposite is equal to side over the angle opposite is equal to side over the angle opposite. Which side do we have for sure? So 15, lowercase b, and we do have the angle opposite, yes? So one of our fractions that we have is little b over sine of angle b, which is 25. Because in any of these here, this is one of the ones we'll use, because we have to have a side and an angle opposite. We do need that. Now we need to determine if we're going to solve for side A or side C first. We're going to have to solve for both. Which one do we want to do first? C. C is going to go on top because, again, it's C over sine of C. So on bottom, we'd have sine of angle C, which is 107. Any questions on this so far? So in the formula, really, we're saying side C over sine of angle C is equal to side length B over sine of angle B. Questions on this here? So we good on how we set this up, yes? Now, if I want to solve, I need to get side length C by itself, yes? So what do I need to multiply this fraction by to get of, not quite, 107? Because C over sine of 107, if I multiply it by sine of 107, they will, over here we need to multiply it by sine of 107. Because if I do it to one side, we have to do it to the, so that will leave us with side length C is equal to 15 times sine of 107 over sine of exactly. Give it a second to load. So we'd have 15 times sine of 7 over sine of 25. We'll round to 2 decimal places. So 33.94. Questions on how we found side length C? What do we think of this so far? Not as bad as you thought this was going to be? The posters on the front wall made them seem worse than they are. We'll not make one of those two, but we will make one of the other ones, yes. Now, questions on this here so far? Because we're not quite done. As we found the measure of angle A, we found side length C, we just need to find the side length A, yes? Now, so here, when we multiply it by both sides, we always multiply it with the numerator. Numerator with numerator, denominator with denominator. Because the denominator of this is understood to be 1. So the sine multiplies with the top, 1 multiplies with the bottom, which doesn't change the denominator. We just multiply it with sine, with 15 on top. Questions on this here? Now, we need to find sine length A, yes? Now, we can use side length C to try to find A, but is side length C the exact value of that side? Well, is this 33.94 the exact value of C? No, it's an approximation. Do we have a side that is an exact value? 15. I like using it. Also, whenever I solve for A, I keep 15 over sine of 25. I use it for both. I use it for both of them. And there's two reasons. One, side length C or side length B is 15. That's a nice number. It's an exact number, so we get a better value of A, or a closer value of what A should be. So not sine of 25 this time, because A is what we're solving for, over sine of the angle A. Well, angle A is what? So we'd have A over sine of 48 is equal to 15 over sine of 25. This time, we're multiplying both sides by sine of 48, because these two will cancel out, giving us A by itself is equal to sine of 48 over sine of 25. What is the only thing different between these two here? Because when we solve for C, what is the angle? That's the only thing different between the two, right? So, in the calculator, the reason this is nice is if you ever use the up arrow, you can go and select something above. If I select this and hit enter, it'll bring it all back down. And what do we say the only thing that's different? Is 48, so I can change it to 48. We can type over the top of it, delete that number, and hit 26.38. And that's it. Questions on this here? Questions on any of this so far? We ready for the next one? Solve the triangle around decimal answers to the nearest 10. So we'll go 1 or 2. So we need to find the measure of angle B, side length B, and side length C. So these are the three measures we're finding. Now out of these three, angle B is going to be the easiest one to find. Because in a triangle, any three angles add together to B. So we can add 115 and 38 together, and then subtract it from 180, and that will give us the third angle. So 3, carry the 1, 3, 4, 5. So we get 153. And if we subtract 153 from 180, we get 27. Any questions on how we found the measure of angle B? So we still need to find side length B and side length C. And in both cases, we're going to have two fractions. Since we're solving for sides, side lengths are going to be on top. What's one of the sides we want to solve for? C. What's one of the side lengths we know? A, which is 25. On bottom, we're going to have sine of the angle opposite that side. So for angle So the side opposite, or the angle opposite side C, is what? So we'd have C over sine of 115. The angle opposite the side length of 25 is 38. So we have 25 over sine of 38. So we have A over sine of A is equal to C over sine of C, where angle C is 115, angle A is 38, and side length A is 25. Questions on this here? Now to get side length C by itself, we need to do what? Yes. Says these here will cancel out, telling us C is equal to 25 sine of 115 over so in the calculator, we can say fraction 25 sine of 115 over sine of, I think it's 28, isn't it? 38, thank you. And hit enter, and we get 36.8. Any questions on this here? Any questions on anything we've done so far? We still need to solve for side length B, yes? So we have B over sine of the angle opposite, or sine of B. Well, B is equal to 25 over sine of 38. This time we're not going to multiply by sine of 115. We're going to multiply by, because here the sine of 27 and sine of 27 would cancel, leaving us with B is equal to 25 times sine of 27 over sine of 38. In the calculator, we can retype the whole thing back out. Do fraction 25 sine of 27 over sine of 38. So 18.4. If you want to do 4, that's fine. If you choose to round 1 to 2 decimal places, round them all to 2 decimal places. Just kind of keep it consistent. I didn't realize this on the first one, but it wanted it rounded to 1 decimal place. I'll take it as 1 or 2. Either one works. And these here are our answers. Now, and these values still make sense with triangles because we said the biggest side is opposite the biggest angle, yes? The biggest angle in this is 115. What's the biggest side? 36.8. Are they opposite each other? Yeah, so it still holds true. Smallest angle is 27, and the small side is still 18.4. Well, this one here, we won't have a hypotenuse. Hypotenuse is only opposite the right angle. Yeah. But that's a good thought because, 90 and hypotenuse are connected. So here, the biggest side would be C. It's just whatever side angle has the biggest angle. Its side opposite it would be the biggest. Questions on this here? We can look at one more of these, and I think y'all will be pretty good, yes? And that's with most of this here. Now, what we do tomorrow, where we're given 2 sides and an angle, there's only going to be one other step, and that's getting the angle out. So just like we did with the other triangles, we use the inverse trig. Here we're just going to be using inverse sine to get the angle by itself. So here we need to find the measure of angle C, side A and side C. Now the way that we know which letters to pick is really just the side opposite. Since we're not given the side length opposite angle C, it's denoted as little c. Side length opposite angle A is little a. It's just a lowercase version of the angle. Now again, we know any three angles in a triangle add together to be 180. So we're adding 85 and 29 together. 4 carry the 1 is 114, and we can subtract it from 180, which tells us that angle C is 66 degrees. Questions on this so far? So this is just, it's not going to, it will somewhat impact the problem, but not a whole lot. Which angle is the biggest? Yeah, B, 85 degrees, yes? What's the side opposite? Would we expect side length A and side length C to be greater than 9? No, and that's a good way to check the problem, because if solving for A, I get a value greater than 9, I know something went wrong. Because side length A and side length C should be smaller, because the biggest angle is opposite the biggest side, so 9 has to be the biggest side. Now we will use it to solve for one of them, because we'll need a side length over sine of the angle opposite. I'll have to solve for A and C. Which one do we want to use first? C. Side length C over sine of the angle opposite, and the angle opposite is. So we'll start off with C over sine of 66 is equal to 9 over sine of 85. What do we do first? Multiply both sides by sine of 66. Because these will cancel. And again, we can plug it in the calculator. Nine sine of 66 over is to 8.3. So I would take 8.3. I would take 8.25. Either one. No. Yeah, because if we did A over sine of 29, we would find side length A first, and then we could go find side length C. And as we said, C's value is still less than 9, yes? So that's what we expected. Now we need to do the other one, which is A over sine of 29 is equal to 9 over sine of 85. This time we're going to multiply both sides by what? Sine of 29. Because the sine of 29 would cancel. And this A is equal to 9 sine of 29 over sine of 85. And again, at this point, we can plug that whole thing into the calculator. So we can say 4.38, we can say 4.4, either one will work. with the measures of the angles, does having side length A be 4.38 make sense? Well, 85 degrees is the biggest angle, yes? Angle A is way less than half of it, or about half of that angle. So 4.5 is half. So it does make sense. They're kind of proportional. If one angle is really smaller than the rest, we expect the side length to be decently smaller than the rest. 66 and 85 are decently close together. So side length 9 and side length 8.25. Kind of makes sense that they're close together. It won't always be proportional, but they will. If the angles are close, the sides will be close. If the angles are farther apart, the side length should be farther apart. Any questions on any of this here? Do we feel comfortable with this here? In that case, you're welcome. Three, 4, 5. I gave y'all an extra one in this. Yes. Geometry and Algebra 2 don't conflict with each other. So they're fine. As long as the classes don't overlap, it's not bad. Now, guys, there is one other thing I will say with law of sines. Now, law of sines works nice. We saw that it does. There is something that we call the ambiguous case with law of sines. Because in a triangle, so guys, before we're done, in a triangle, we know that these three angles here add together to be 180, yes? Now, what we have issues with, especially with angles, is if we say sine, let's see here, of 80, because I'm trying to, it's pi over 2, and I want to say sine of, let's see here, 120. Sine of 120 is this here. Now sine of 60, that'll be better. Sine of 60 degrees and sine of 120 give us the same value, yes? But the overall sides are not going to be the same. So if I said sine inverse of this here, which we got for 60 degrees, we do get 60 degrees, yes? Now if I say sine inverse of the value we got for when we took 120, we get 60 degrees. So this is where sine inverse or sine law of sines falls apart a little bit. It still works, but we can get multiple triangles. However, for what we're doing in here, you're only going to have one. We're only going to have one case. We're not going to deal with the ambiguous case. Yep, there is no